Alright guys, so I did forget one little part of the notes. I know I said the last video was the last one, but we did have just one more little section of notes, so we're going to go through that real quick. I promise it won't take long. We do have some scatter plots that we will run into from time to time that will be nonlinear. And what this means is they can't be modeled by a straight line. What we're going to find is that sometimes data may be instead modeled by a quadratic or an exponential function. To tell what is the most appropriate model, we need to look at the shape of the data when graphed on the scatter plot. So basically what we are going to be doing is we're going to look to see whether our dots form a straight line, and let's pretend that that's straight, and if so, that would be linear. If it makes a U shape, it's going to be quadratic, and if it gives us an exponential curve, it's going to be, of course, exponential. So if we look at these examples below, if we were trying to draw something that would be a model for these datas, if you looked at these dots are forming a U. So this would be a quadratic model that would be most appropriate. And we aren't going to get into how you would actually find those, but if you were for some reason asked to draw one in, you're again going to kind of do it by hand, just like when we were doing the line of best fit. And you're going to try and draw the U shape that best fits the data. Now if we look at our second example, this is like the examples we've been looking at. These dots are forming a pretty straight line, so this would be a linear example or a linear model that you'd want to use. And our last one, you can see it's not a straight line, it's not making a U, it's making a big curve, so we're going to label this one as exponential. And again, you could sketch in a line that goes something like this. Alright, so now this really is your last notes video. Congratulations. Thank you for sticking through this last one. And go ahead and work on your practice.